Tonight on Catalyst, probing the ocean bed for signs of earthquakes.
Japan is due for a major earthquake, but can scientists predict when?
G'day, welcome to Catalyst. The devastation caused by Mother Nature's upheavals to the Earth has been enormous, of course. Throughout history, earthquakes and tsunamis have caused mass loss of life and major destruction to property. Now, we can't do anything about the sheer power of these events, but if we could better predict when an earthquake would occur, we could save thousands of lives. Well, Dr. Mary Macy joins researchers who are going to drill into one of the most earthquake-prone places on the planet.
The land of the rising sun. Rich in tradition and rituals. Intertwined with contemporary living. Japan is spoilt with mountainous landscapes and peaceful gardens. But it's here where Mother Nature has for millennia unleashed her fury, wreaking havoc, a tirade of tsunamis and earthquakes, leaving a path of destruction with little warning.
There will definitely be another earthquake at some point. It's just a question of when.
Aboard this vessel, I meet up with scientists working on the edge of earthquake zones. They hope they can predict when the next big one will strike. In the distance is the Chikyu, an engineering marvel. It's the largest scientific drilling vessel in the world. On board are a group of international scientists who've been exploring one of the largest, most earthquake-prone regions on Earth, the Nankai Trough. Just 900 kilometres south of Japan's island of Honshu, the Nankai Trough lies along the Pacific Ring of Fire, where 90% of the world's earthquakes occur.
From a scientific point of view, it offers us the best chance to really understand earthquake mechanics, what causes earthquakes to happen.
Japan is near the intersection of 4 tectonic plates. Deep beneath the ocean in the Nankai Trough, the Philippine plate subducts the Eurasian plate. The movement and collision of these plates is both unpredictable and loaded with potential seismic activity.
Because there's a large surface area of contact between the two plates, they generate the world's largest earthquakes. We talk about magnitude 8, magnitude 9 earthquakes, these giant earthquakes, like the Sumatra earthquake in 2004. The plates are moving together at some very slow rate, usually about the rate that fingernails grow, a few centimeters per year. But if the fault is kind of stuck together, then those far-field motions build up stresses around the fault zone, and those stresses continue to build until they finally overcome the strength of that rock, and then it breaks catastrophically.
In Japan, early warning systems have been in place for over a decade.
More than 1,000 sensors distributed on land, and seismic wave data collected from seismometers produce the early warning of earthquake.
We are not very good at predicting earthquakes.
Early warning systems are very poorly effective at the moment. We're always looking for ways to do this better.
The only way to improve early warning systems is to get closer to the epicenter of earthquake zones. Here, geologists sample rock layers in order to reveal secrets to the timing of the next big earthquake.
So the Chikyu is one of the most advanced tools that we have to study earthquakes because it provides access to these deep parts of the fault zone that otherwise we would never be able to sample or to monitor.
Just the sheer size of the ship catches your breath. It's over 200 metres long, and the total length of the drill pipe is 10 kilometres. The drill can reach the Earth's mantle, a depth no other ship of its kind has ever achieved. This integrated ocean drilling program has instruments built to survive searing heat, crushing pressures and corrosive fluids. Boreholes are subject to enormous pressure and can cave in. To prevent this, riser drilling technology uses mud within the hole instead of the usual seawater. The mud's greater viscosity helps resist the pressure.
In riser drilling, one of the real advantages we have is the use of something called a blowout preventer. And this is basically a large device, it's like a giant valve that goes on the seabed and actually allows us to control the pressure in the borehole and keep it stable.
GPS-guided thrusters hold the 57,000-tonne Chikyu in position through harsh weather conditions and heaving seas.
You need some way to allow the ship to move without pulling the drill pipe in and out of the ground. And that's done, this big yellow thing in the derrick is it's called the heave compensator. And that's exactly what it does. It acts as a giant shock absorber. So the ship can move up and down and the pipe stays still.
Soft rock layers are pierced by hydraulic piston corers. Sharp and tough, it takes just 1 second to penetrate 10 metres. A rotary corer is used for harder geological layers. Once collected, the samples undergo CT scans and are analysed for density, heat conduction and sound velocity. Dr. Huftal looks for active faults in the rock to assess the size of earthquakes.
And this layer is a fault that is entirely parallel to the bedding layers within the rock.
Testing the strength of the rock reveals just how much stress the geological layers can endure before they break. To learn more about future earthquakes, scientists must look at the past. The chemical properties of geological layers also hold clues to how the Earth's climate has changed over time. To improve early warning systems, scientists will also place monitors in the boreholes to get real-time information.
You actually have a drop in fluid pressure right before an earthquake. That's the theory. And so by monitoring fluid pressure, it may very well be predictive.
These monitoring systems are really critical to that because being able to, in a sense, take the pulse of the Earth and sense or measure the buildup of those stresses is a huge step toward predicting in the longer term.
Currently, we have almost no observatory in the seafloor. If we have the sensors in there, we can issue early warning, maybe 10 seconds earlier.
Currently, they can issue a 10 to 30 second warning, and another 10 seconds doesn't sound like much, but every second counts when it comes to saving lives.
I think this research is right at the cutting edge of marine tectonics and geology. The combination of drilling deep boreholes and the instruments that we're trying to put in for real-time, long-term measurements. Nobody else is really doing it.